When we're trying to evaluate an inverse trig expression, the first question we always have to ask ourselves is our x value within the domain of our inverse trig function? So to do this, I'm going to be referring or taking a look at this chart right here, so hopefully you have this handy. Recall that our domains for our inverse trig functions were these over here. So I've got to make sure that my x value fits within these values, whether I'm working with inverse sine, inverse cosine, or inverse tangent. So going back to our problem at hand, the domain of inverse tangent was between negative infinity and positive infinity. In other words, everything works. So everything is going to be within our domain for inverse tangent. So what I want to do then is, if that value is positive, I should be able to find it within this chart that we've taken a look at before. Sorry, this chart here. So we were working with tangent. So I want to go ahead and look down until I find a side ratio that is what I have. So I'm working with 1, which means the angle that's going to get me that ratio is back here, just pi over 4. I'm always working with radians from now on. I'm probably not going to be working with degrees too much. So pi over 4 is the angle we're looking for. So back to our problem then. The inverse tangent of 1 is just pi over 4. And we can check that using a calculator. Just type in inverse tangent of 1. Now you'll get a decimal, but you can then type in pi over 4 and make sure it's the same decimal. When we're evaluating inverse trig functions, we're looking for missing angles. And so what I found was that, if I want to rewrite this a different way, I found that the tangent of pi over 4 is equal to 1. That's all they were asking me to do. What's the angle? That gets you a tangent of 1. So I've got it. All right. So next up, I've got the inverse sine of 5 pi over 4. Well, remember, the first question we always want to ask ourselves is that in our domain? The domain of inverse sine is just between -1 and +1. So I can see that I've got a problem, because 5 over 4 is bigger than 1. That is not within the domain, which means I can't even get an answer. The answer is there is no answer. It's undefined. There is no angle that will get you a sine ratio of 5/4. And if you think about why that will work, just a quick side note down here, always go back to right triangles. That's all this trigonometry stuff is. So let's say that's the angle we have right there. So sine, remember, is telling us we've got an opposite side, which is 5, over hypotenuse. And if you look at that triangle, it's an impossible triangle. Do you see why? You can't have a hypotenuse longer than one of your legs. So since it's an impossible triangle, it's an impossible ratio to get. So there's a couple of our easy situations when our x value is within our domain and it's positive, and when our x value is not in our domain, the answer is just undefined. So let's go ahead and take a look at ones that are in our domain, but they're not as easy as just looking up in our chart. So first of all, inverse cosine of -√3 over 2. Well, recall that the domain of inverse cosine is between -1 and 1. So this does fit in there. Now I may have to use a calculator to just double check, but if you type in -√3 over 2, it'll be a decimal that's between -1 and 1. So it is in there. Unfortunately, -√3 over 2 is not in this chart. However, I should be able to find the positive version of it. So I'm working with cosine. If I look down my cosine column, well, there it is. There's the positive version, which tells me that the angle somehow is going to involve pi over 6. Well, it's not necessarily my answer itself, but it will help me find the answer. Here's how it works. So let's go ahead and sketch out a diagram of what's happening here. One thing I got to figure out before I actually get my answer is, again, going back to this chart, and I want to look at the bottom down here. Look at where inverse cosine exists. We decided that inverse cosine is only going to exist between 0 and pi, or those top two quadrants. Well, quadrant 1, inverse cosine would be positive. Over here, inverse cosine would be negative. And this is no big secret. This just goes back to the ASTC thing. We're just not allowed to pick the bottom quadrants. So sine is positive, anything else is negative, so cosine is negative there. The reason that I needed to know that is, since my cosine is a negative angle, I want to draw this pi over 6 in the quadrant where I have a negative cosine. Well, we just said that that's going to be somewhere over here. So that's where I'm going to draw my angle, which is where cosine is negative. My reference angle is pi over 6, but remember I said that's not necessarily our answer, because when I measure this angle, I still need to measure from the positive x-axis around this way. That's how we measure inverse cosine. So if this angle is pi over 6, and I recall that this is 1 pi, if you think back to how we originally graphed these, I am 5 pi over 6 short of where I need to be. And you can do some, if you're not great with fractions, you can do some subtraction. 1 pi or 1, minus pi over 6, or 1/6, is going to get you that 5 pi over 6, which is your answer. Now, these are easy enough to verify using your calculator, so even though we're not using a calculator to get the answer, I would still check these on a calculator, type in inverse cosine of negative square root of 3 over 2, and you'll get some big, crazy, irrational decimal, but then type in 5 pi over 6 and see that it is the same exact decimal. So a little more involved when we're not within that chart, but hopefully nothing too bad, especially once you try these and get the hang of them. So let's, speaking of that, try a couple more. So I want to find the inverse cosine of, or inverse sine, sorry, of -1. Well, again, my first question is that in the domain? The domain of inverse sine is between -1 and 1, and so yes, it counts. The brackets mean they're included. But with that -1, it's probably not going to be in this chart. So let's take a look and see what we've got. Let me erase a little bit. Hang on one second. Alright, so looking down the sine column, and remember we can go all the way down to quadrantals, I see a +1, which tells me my angle is going to be pi over 2. We're going to talk about that in a second. So pi over 2 is somehow going to be involved in my answer as that missing angle. So here's what I'll do. Let me go ahead and sketch this. So pi over 2 is up here at the top of my circle, but that's where it's 1. I don't want to get to 1. I want to get to -1. Well, that's got to be down here then, the opposite angle. So sine and tangent, it's actually pretty easy to find these, just you kind of change the sign of your angle. Negative pi over 2 is going to be the angle that I want to use, and again we can verify that using a calculator. One quick note about that chart I said we'd talk about. Some people realize that, hey, -1 is in the chart and it's 3 pi over 2, so why is the answer not 3 pi over 2? Well, again, think back to where we're allowed to find sine. Sine inverse sine has to exist between these two quadrants. So if I measure 3 pi over 2, I'm ending up down here. That's where 3 pi over 2 would be, but I'm not allowed to measure that way. I can't go around that way. So rather than going that way, we take the shorter way, which is the negative pi over 2. In our example. Okay, and so one last one we'll take a look at, the inverse tangent of negative square root of 3. Well, again, I want to first check if that's in my domain. Domain of inverse tangent is between negative infinity and positive infinity. So yes, everything's in there. So this one should work. I'll go ahead and go to my chart. Now I'm not going to find negative pi over 3, but I should be able to find pi over 3. And in fact, there it is right there. So it tells me that somehow pi over 3 is going to be involved in my answer. Not necessarily my answer, but it should be involved somewhere in my answer. So once again, I want to think back to these circles. Inverse tangent exists just like sine. It exists between those two quadrants. I want to look where tangent's negative because I'm dealing with a negative ratio. So I'm going to take that pi over 3 angle we found in our chart, but draw it where tangent's negative. Tangent's negative in that quadrant. It's positive up here. It's negative down there. So measuring this angle clockwise, since I'm measuring in the opposite direction, tells me my angle I'm looking for is a negative pi over 3.